So today we are going to discuss about working of VCD, vigilance control device, in three-phase loco. So why we need VCD? So we need to check the alertness of the crew, LP and ELP, by getting a signal from whatever the actions he is doing, performing in regular operations. That is converted the electrical signal that will be given to VCD. So if that signal comes, so we can assure that he is alert. So it is checking for every 60 minutes. That vigilance cycle is set into 60 minutes. For every 60 minutes, the vigilance, sorry, 60 seconds. Uh, uh, for every 60 seconds, he has to perform some operation. Then only that VCD cycle gets resetted. Resetted means it's again going to 60 seconds. So it is coming around, counting down 60 from 59. That it will by going up to 0. So in that period, if any input signal is coming to the VCD, then the timer will again reset to 60 seconds. Then countdown will start. So by that only we can assure that we can aware that the visual LP is alert. So we are getting the alertness of the driver through the VCD. So what are the vigilance reset signals? So in three-phase locos, in converse locos, there are a lot of signals available. In three-phase locos, what are all the reset signals? That signal which can reset the vigilance cycle. So one is the movement of the driver angle transmitter. So he is performing that angle transmitter. So movement means more than 3%. From the earlier value, it has to be more than 3%. If it is set in some angle, means some power. If it's permanently in that angle, that vigilance will not be taken. It is not counting. So the difference has to be more than 3%. So that signal again reset the vigilance cycle. Then operation of standard. If he operates a standard, then the vigilance cycle also get recycled. Means reset means again it will give the firstly start the 60-second time countdown timer. And if none of the signal is available, we can use that BPVG. So he has to prove his alertness by pressing the BPVG. Now BPVR also, in that also one additional switch is provided, because recently we have removed pedal switch, MS4 505 modification, that we have provided some rhythmic operation they are doing. LP is doing rhythmically operating PVCD without alertness. So they have removed the pedal switch. Instead of that, BPVR also additionally provided that interlock, BPVG interlock. So if none of the operation available, he can prove his alertness by pressing BPVG or BPVR. That signal will reset the vigilance cycle. So if he is not, if in this 60-second cycle, if he is doing some operation, that vigilance cycle will never runs out. So if he is not performing any operation within this 60-second period, then what will happen? The next, that VCD should alert. VCD is alert the driver by giving a one warning lamp, flickering of warning lamp. That is called LSVW. So there is the first, that vigilance cycle has over. Now we are coming to the warning cycle. That warning cycle, first 8 seconds is giving, it is VCD will give alertness. So are you aware? Are you alert? So that you have not performed any operation during the vigilance cycle first 60 seconds. So I am blinking. That LSVW is blinking to check the alertness. In that period, he cannot perform the VCD reset signal. Only he can press BPVG. So it is allowed only to press the BPVG. That only can reset the vigilance cycle in the warning cycle period. So if he press the BPVG, then vigilance cycle will reset. Again it will goes to 60 seconds and countdown starts. It is waiting for that any input from LP. So if he is not acknowledged that first 8 seconds, that vigilance warning LSVW, he has not acknowledged. So then he is not alert. That VCD is giving one more option of warning buzzer. So it is attracting LP's alertness. So by giving warning buzzer, that signal is given. Sound with the LSVW. Additionally, that buzzer will sound to alert LP. Means he is alert or not. In that cycle, he has to, if he wants to perform an operation, only then BPVG, only after that vigilance cycle, only BPVG is allowed. So if you press the BPVG, then again the vigilance cycle will reset to 60 seconds. So this is the second time also it is allowed. If he misses the warning vigilance cycle 60 seconds, then LSVW warning cycle for 8 seconds, then LSVW with buzzer sound. In that period, if he performs operation, then VCD will allow him to operate without performing any operation, any brake application. So he is allowed to take further action. So if he in E70 locus, in KB locus, these two cycles are there. First warning light LSPW for 8 seconds, then after that continued with buzzer for 8 seconds. In VCD in E70 locus, both are coming at the same time. After 60-second vigilance cycle, warning cycle for 8 seconds, yeah, lamp plus buzzer will simultaneously comes up. In that 8 second, he has to perform the vigilance reset signal. BPVG has to press. Otherwise, what will happen means, so VCD is for the first 60 seconds, there is no signal from the LP. Then for the next 8 plus 8 seconds, there is no signal from LP. So it is deciding that LP is not alert. So it has to take the action. So if LP is not alert means that is a dangerous situation. Then it has to initiate the penalty brake, means automatically applying the brake. So automatically applying the brake means the train will stop because of the inactiveness of the LP. He is not acknowledged any. He has not given any input to the VCD. The penalty brake will apply. The train will stop. So by then how the train further can be run means he has to during the penalty brake cycle he cannot perform any operation. That will once it is activated means it will apply the brake. So any signal from the LP cannot reset the penalty cycle. Penalty cycle once happened means it has happened. So how to reset the VCD signal? VCD. He has to bring down the angle transmitter to 0 position. Then he has to press the vigilance reset push button available. That was in KB only after expiry of 32 seconds from the penalty braking. Once from the penalty braking, once the penalty brake starts, after 32 seconds only, he can be able to perform the VCD reset. In Fevli locos, it is 2 minutes, 120 seconds. After 120 seconds, after the penalty brake, expiry of 120 seconds, only he can be able to perform the VCD. So the fault code F1003P1, emergency brake vigilance, is recorded in VCU. VCU will display that message. So this is the two type of VCDs available in our logos. This is called KBL. Norbrums, it has some LEDs for indication. This is a Fevli. There is no all the inputs cannot be inferred from that LED signal. Whatever the input comes, that we cannot infer. Only the goes inside. So this is a vigilance reset signal. That means the BPVG or BPVR signal. This is the intermittent activity signal. That means MP movement, angular transmit movement. If it is more than from the earlier position, it has to more than 3%. So that will reset the vigilance cycle and the standard. So vigilance suppression signal. So we are a vigilance resetting signal we have seen. Vigilance suppression signal means when there is no need of vigilance. When there is no need of vigilance means when the driver apply the brake, there is no need of vigilance. So from it need not to monitor the LP. And when Loco is in standstill position also, there is no need of vigilance. So this signal is permanently suppressing the VCD. That VCD will not work. If Loco is standstill position, if it is less than 1.5 kilometer speed, then VCD will go to automatic suppress mode. That VCD will not work. And in brake applied condition also, it will not work. That is a signal that is coming from a VCU, vigilance control. That one signal is coming to VCD. So if it is less than 1.5 kmph, so this signal will be high. If this signal is high, means VCD will be in suppressed mode. And it is by taken from the BC. So if it is brake is applied, in that condition, if it will get a high signal. If high signal means VCD is suppressed. So this is the power on circuit. there is one switch available, 237.1. So if it is in one position, the VCD will work. If it is in 0%, that means VCD is bypassed. When we are doing bypass means if there is malfunctioning in VCD, if it is malfunctions, then we can go for VCD isolation. So then mere on the vigilance VCD will not start the vigilance cycle. One cab has to be occupied. So when a driver turn the BL key on any one of the cab, then only that vigilance will start. That is the signal here shown. So this is a VCD circuit. This is called the VCD 237 called VCD unit. This is 11A on that circuit. So here we can see that power on signal and BL, and this is a VCD suppress signal. One is from low speed and another is from BC. So this is a intermediate signal, that BPVG signal. So acknowledgement BPVG and BPVR signal. It can reset the vigilance cycle. Then this is a penalty. This signal, the VCD penalty reset signal, BPVR. Only after expiry of penalty break, we can press the switch. We can reset. We can start the train after a penalty break application. This is a reset vigilance penalty break. After the penalty break application, that master controller has to bring back to the 0%. So the reset the throttle. If it is come to 0%, it will be high. It will give the high signal. Means that MPS is to move to 0%. There is no traction. We are not taking. After penalty break, it has to bring down to 0 to reset the VCD. So this vigilance reset. That vigilance reset means if the angle transmitter moves by 3% or pressing of stander, it will give a momentary high signal to that VCD by VCU. This vigilance reset signal coming from not directly coming from stander. That standard signals are going to VCU. That VCU give the output signal to the VCD. So if stander is pressed or angle transmitter is moved, then one short pulse will come to that VCD. Then the vigilance cycle will reset again to 60 seconds. So this vigilance warning lamp, first warning cycle LSPW. It's a 24 volt. So after the expiry of vigilance cycle 60 seconds, if he is not performed any operation, that warning lamp will blink to alert the driver you have not performed any operation. So are you alert? That signal. Then after that one signal goes to buzzer. Buzzer, how it goes meant to the VCU. It is going as an input. Vigilance warning. So that VCU will generate a buzzer signal. So after the expiry of 8 seconds, then the next 8 seconds, this signal will be high. So here it is that IP wall or the emergency brake wall. So how it is going means from the E pin, that's the output of VCD. It is given, this 3000 is giving a permanent high signal when there is no vigilance. In normal condition, there is no penalty brake. This signal will be high. So it is going to the BPMS and again going to the speedometer NC interlock. Speedometer NC interlock for overspeed. If it is if detects overspeed, it will open. Then go into the IP wall. So if the expiry of vigilance cycle and warning cycle 1 and warning cycle 2, this signal becomes 0. Means output will not be there for a penalty brake. So during the penalty brake, this signal becomes low. Then it will deactivate the emergency brake wall. So the train will be stopped. So this is a VCD circuit. So we are earlier we said that VCD is malfunctioning. Then the switch 237.1 is there. So it can turn to 0%. If it is in 1%, this will get the power 110 volt DC. If it is in 0%, it will not get the power. But we have to maintain that output supply to the emergency brake wall, that's IP wall. So how it is happened means here 237.1 is available. So here it is 0%. This interlock will give the supply to the emergency brake wall. It will bypass the VCD. It will give the high supply to the direct supply to the emergency brake wall. So that VCD unit, any VCD unit is bypassed through this switch. These are the VCD.